today we will be learning about Android performance optimization tips, as you can already see. So let's get started. All right, and before we get started, just quick information for you guys. You can follow our Instagram and Twitter page at @thecodecity, as you can see here. Follow me on Instagram or on Twitter for more daily updates. All right, now let's get started. So these are the things that we will be learning about. And when I was trying to think of stuff for this video, I was thinking of the things that I usually do, some of the things that I usually do, and then I googled a bit, and then I found this website, Android's official website, and then I said, hey, this is good, and I took these things from that website. I'll have the link in the description below, but I know since you guys like videos more, I have created this video for you so that you can check it out. And some of the examples are what I do in real life, so the examples are my own. Okay, so let's get started. So we'll first be learning about how to avoid creating unnecessary objects. So this is a pretty simple thing that we just skip and we forget when we are doing. So if we keep that in mind, then this is very helpful. And if your app has is a huge app, then creating unnecessary objects can take a lot of memory. All right, so when do we prefer static over virtual methods or functions? So we will see how it can improve our performance, and why we should use final for constants, and we will see how to use enhanced loops for better performance, and we will see what this is consider private access if private class accesses private method. Yeah, so if we have an inner private class and that is accessing a private method of the outer class, then it takes a lot of there's a lot of unseen performance overhead in that. So we will discuss about that too. And this is not visible, but I know you guys can figure it out. Avoid using float where int. Let's just move this for a while. Avoid using float where int is sufficient. So this is pretty common. Let's not say common. This is pretty how to put it, common. It's like common sense, and I didn't want to include it here, but since it was in the official website, I included it here. So just so if you are in the habit of using float wherever you want, don't do that. That's not good. Okay, don't do that. All right, so let's get started with the examples. Okay, first, avoiding creating unnecessary objects. Where is my so here we can see we have a method here, getString, and then we have this string name as a parameter, and then we are doing some operation. Now this is just an example, guys. You can do a lot of things here. Maybe this is validate email, and you have an email here and you are validating the email, so the kind of stuff. But since this is just an example, what we are doing here is we have been passed a parameter here, right here, and then we are adding or appending hello to it, and then we are assigning it to a variable, and then we are returning the variable. So as you can notice here, this hello string is not being used anywhere before returning, right? This is not being used anywhere. So what we can do is a better way to do it would be like this. So we are just getting the variable and just appending and returning without creating a variable here. So no variable is created, no memory is allocated for that, and garbage cleaner does not have to worry about that if you can do this. Okay, so this is a pretty basic example. A better way to do that, a pretty common example will be this. So we do this in if you have done databases with Android. So this is a pretty common example for that if you have used databases. So what we do is we create an instance of this database helper whenever we want to do an operation with the database, like insert or get or update. So to do that, we use this. All right, but let's say you have a few fragments in one activity and you have multiple activities. So what you do is, whenever you want to operate with a database, you create an instance of this database helper, SQL database helper. So instead of doing that, what we can do is we can create a static method, getInstance method, that creates an instance within this class, like we are doing here, right? See, we have this sqdb helper instance. So this, I have not included the class name here. So this variable has the class, this SQL database helper class. So it's SQL database helper sdb helper instance, and it is null in the beginning. So when we call this get instance method, and as you can see here, this is static, so we don't need to initialize this to call this method. So when we call this method here, what happens is first first we check if this instance is null, right? If this is null, so if this is null, then we create a new instance, new SQL DB helper, and then we return it. Okay, so this is just initialized once. And if you have 10 fragments and you are calling this get instance method in 10 fragments, this is not being initialized every time. It is initialized only when it is null. So a lot of duplicate instances are avoided in that case, in your fragments or in your activities. So this is a pretty good example, and it has improved my performance in the past a lot, guys. So keep this in mind, keep this one in mind, okay, whenever you are creating databases. Nowadays you use room and that kind of stuff, but if you're still creating a database helper, use this, okay, or use this whenever you can, if you have a similar situation. All right, so let's move on to the next part. Okay, now here we have prefer static over virtual. What this means is, let's go here again. Now we had improved this by removing this variable, right? And by removing this, we directly returned it. Now how can we make this even better? Okay, how can we make it even better? So as you can see here, we are just getting the parameter, and then we are not doing anything. No, let's not say not doing anything. We're not accessing any other variables or fields outside this method. Okay, so we are just doing whatever we want to do within this function. Let's say we are 100 line or 200 lines of code. But if we are not accessing anything outside that is not static, we can make this method static, and that increases the performance by around 15 to 20%. So you can do it like this. Just add the static here. So what this when you can do this when you're not accessing any fields of the class. So this can be made static, and it increases your performance by how much? 15 to 20%. All right, pretty good one. Another one. All right, that's what DJ Khaled would say, but I'm not DJ Khaled, so I'll just say another one. All right, let's move on. Okay, so okay, we did this. We know how we can create static methods instead of virtual. Now let's see when we want to use final for constants. Now, the first case here is we have this static int val 42, and another string variable is also static. Now, as you can read the comments here, class needs to be initialized for these variables, and these variables are accessed using class. So whenever you do something like this, now we can access this using the class name, right? Class name.intval, class name.strval, but the compiler needs to initialize the class so that these can be used. Now, if I was you, I would say better this is, but since I'm not going to say that. I'm saying a lot of these things lately. Okay, I'll stop. Not funny. Okay, so static final int val. So what we do is we add final here instead of in addition to static, in addition to static, we add final here. So if we add final here, what it does is it is included in I think the dex file, and the class does not need to be initialized. So you can research more how it works, but the bottom line is, if you have a static variable, you can just make it final so that the class does not need to be initialized for that. Okay, so but if you make it final, it will not be able to be is that correct? All right, if it is final, then it cannot be changed later on. So if you have variables that aren't changed, like base URLs or API URLs or request code or something like that, you can just add final also in addition to static, and that will improve your performance. Okay, booyah. To the next one. Okay, so how we can use enhanced for loop, enhanced for loop. Okay, fourth one. So here's three variables functions for you. The typical way, the way we learn in our Java classes in our college, or anywhere if we had learned Java. So this is the typical way to do it. You do int I equals to 0, and then you get the length of the array, and then you increment it, and then you do whatever you want to do. All right, this is the basic one, this is the second one, this is the third one. Now take some time, pause this video, and try to think of reasons which one would be better, and just let me know in the comment section below. You gotta use your brain, you gotta think for yourself. So I suggest you to pause the video, go over the code, and just think without googling, just think which one could be better. So even if I'm not sharing this video, even if some things are not in this video, if you can think for yourself, this is not better, this would be better, that is very good. That is a very good thing. You can improve your own code that way. Okay. I was paused. So okay, so let's go over which one is better. First one we have already seen. In second one we have only changed one thing, right? Instead of doing I is less than array length, we have used len equals to array.length, and then we have compared it to this length. So in the terms of speed, this one is better, as if let's say there are 1000 items in the array, then this array.length is calculated every time. Okay, each time the loop is executed, each time the loop is executed, we get the array.length, and then we check if it's less than I, greater than I, and then again I is incremented, and then we get array.length again, and then we check if array.length is greater than I. But here array.length is not changing here. Okay, it is not. So we just get the length here, and then we compare it with the length each time. So each time the loop is executed, we are not getting array.length each time, we're just checking it. So if the loop is 1000 times, then you don't calculate the array's length 1000 times. So already 1000 operations are reduced. So this one is better than this one. Okay, now I think this one was introduced in Java, I am not sure, but I think around Java 5. I might be wrong. If I am, let me know in the comment section below. And okay, so in here what we are doing is, so the syntax is like this. If we have an array, we just do int, that is the type of item that array holds, int a variable name, and this colon, and then the array, not this array exactly, the array name. So what we do is we do the data type that is stored in the array, a, and the array. Now to do this, the type here, the collection here must be iterable. What do you call it? Iterable. So if you do this, this has a better performance than this. Okay, but it uses an iterable or iterable. Okay, I'm going to say iterable. It uses an iterable whenever you are using this. Okay, and if you use iterable on your own, since we have not used it here or here, if you use an iterable on your own, that is difficult to code. Not difficult, that is more code than this, but the performance will be same. Okay, so in that sense also less code is better. So this has less code, so this is definitely better. So if we have an option of doing this, you can use this, but this does not have more control. If you have to use, if I is even, then you have to remove it, then you can use this. And because you don't have an I here, you don't know which part of the which position in the array you have reached. So this is better, cleaner way to write. Also performance is also good, but if you want more control over the array, use this one. Okay, all right, so we are done here also. Now okay, this one, we are here on the 5th part. Okay, this is it. Now excuse me, but guys, excuse me, I just ate chickpeas. All right, you didn't need to know that. Anyway, we are here. So in public class foo, this is the public class, and in here, now just a quick note, don't be think, oh my god, what this is, what is this. This is pretty simple. I'll just explain to you one by one, so you can get it. No need to try to read it, try to read it and try to explain it on your own. Just follow along with me, and if you don't get it, you can pause the video and try to understand it. So first we have a public class here, and then we have a private class here. Okay, and then this private class is accessing this method here, do stuff, and we go here and we check it. This do stuff is a private method. So in object-oriented programming, what is the rule? The rule is, if a class has a private method, that private method cannot be accessed by another classes. But here we have an inner class, but this inner class is accessing this private method, right? So how is it possible? Now it is possible because Java allows you to write this code, all right? But what Java is doing is, it is creating some XSS methods on behind the scenes. So again, let's quickly go over what we did here. There's a public class, and inside the public class there's a inner class, and then this inner class is accessing the private method, right? Private method of the outer class. So they cannot be done because this private method cannot be accessed by another classes. But Java allows us to write this code because Java behind the scenes adds XSS methods. So these are the accessor methods. So remember this, even if you don't get this properly. Whenever you are using an accessor method, or whenever accessor methods are used behind the scenes, that is increasing your performance overhead, not increasing your performance, increasing your performance overhead. So your performance is actually decreasing. So whenever you are using accessor methods. So okay, now here what we are doing is we are accessing this do stuff, that is a private method, right? So what happens is Java creates this static method here, foo.access $2000, this private this static method. And what this is doing is, this static method is calling this do stuff from this foo class. Okay, so to access this do stuff, that is a private method, as you can see here, do stuff is private. Java creates this static accessor method, and to access this foo m value is also static, as you see here. Okay, it's not sorry, not static, private. M value is also private, and to access that private value, Java creates this another static method to access that private field, and these are created whenever you. So these accessor methods are created whenever you access a private method from an inner class. Okay, so don't do this, guys. If you have some methods here and fields here, just remove the private, if that is possible in your design case, may remove the private so that it can be accessed here without these accessor methods. But one thing to remember is, if you remove the private here, then these methods will be able to accessed by all the other classes in the same package, whatever that is. If I messed up my sentence, that's like, this can be accessed. Okay, if you remove the private variable here, this int value and this do stuff method can be accessed by any class in the same package. They need to be in the same package. So if possible, try to remove the private and make it give this field and this method private access. That way these don't need to be created and your performance increases a lot. Okay, if you don't get it, just let me know in the comments. I'll try to answer your queries, and we are done with this. Okay, the last one, I'll move myself here. Okay, I'm here now. Hey, magic. Okay, so I am just going to say it. Avoid using float where int is sufficient. So as I said it before, if you don't have, what's the use of saying 10.0, 11.0, 20.0 if it's just going to be 0.0 after 0 after the integer part? So if you are doing that, what's wrong with you? Don't do that. Anything wrong with you? Don't do that. Just don't do that. Okay, so if int is sufficient, just use int, don't use float, because if you go into the details, the float takes twice as size as integer, and it takes twice as memory as integer, and double takes twice as size as float. So if you have to choose between double and float, you can choose double also, because nowadays we have like 4 gigs, 2 gigs, 6 gigs of RAM, and just a small double of float is not going to change that. But accessing speed between double and float is same. But if you use float, the speed, the cost is double, so if possible use int. And okay, one more thing, one last thing that I would like to say to you is, we have gone through all these examples, and somewhere we try to reduce the variable to increase to take less memory, and in another one, okay, where is that, let me show you the example. Okay, I'll just move myself back here, it looks odd on that side. Okay, now here we remove this hello string, because hello string was not being used anywhere and it's just being returned, so we removed it, and that way we didn't assign it, so an operation is reduced, and then we didn't return it. Memory is also memory usage is also returned. So one thing is, but here, okay, not here, okay, why is it not moving? Okay, here, but here, see, there's no extra variable, but there's no extra length variable, but we are using this operation here. So you might argue that this len increases memory usage, but maybe it does. But the thing is, whenever you are faced with like what to choose, higher memory usage or better speed, so always choose speed these days, because speed, your user is very much dependent on speed. Speed is very of the driving factor these days. Memory is cheap, memory is cheap. A lot of phones have a lot of RAM, a lot of hard disk, so memory is just this small thing is not going to change it. Okay, so if you are what do you say it, in a dilemma what to use, better speed or better memory, do both. But if you have to just pick one, always pick better speed these days. Mostly you use better speed. So that is the last thing that I was going to say. So speed is memory is cheap, speed is not. Speed is a driving factor, so always choose speed if you have to pick one. So that was it. Also, I will be sharing these these image samples and stuff in my social media, so follow @theCodeCity in Twitter, Instagram, and Facebook. Follow it, and if this helped you, share it, and hit the like and subscribe button, and if just hit the notification button too, so that you can see this handsome face whenever I upload the next video. Alright guys, peace out.